So for number 15, as far as how this compares to what you did in class yesterday, the first equation is already set up, so that's very convenient. It already says y equals. Please remember that in every single one of these problems, you need one of two things. Something says y equals, or something says x equals. It doesn't matter which one you do, but one of those two things has to be happening. It's kind of hard to see, but this is a 3y. So we already have that here, y equals, that's great. Because we already have that, I can plug this equation into the other equation right away. One thing that people may look at in this and say, what the heck's going on, is why does this look this way? Where it's got 3y minus x plus 3 and then equals 0. Everything's on the left. It doesn't really matter what the other one looks like as long as one of them already says y equals. The fact that it says y equals, you have to interpret this as plain English, basically. Y equals saying y is. Or instead of y, I can plug in this. So what I'm going to do is I'm going to take this right here, and instead of y, I'm going to plug this into that equation. When an equation says y equals, it's telling me that I can replace y with whatever's here. So, I'm going to take this second equation, but I'm going to replace y with what's in the first equation. So everything in this second equation is exactly the same, but instead of y, I'm going to write what y is. Y is this. So negative 2x plus 6. The reason we're doing this, I'm not sure if this was clear before, the reason that we're doing this, you can't solve one of these equations if it has two variables. But if I plug this equation into that equation, I only have one variable now, x. I have x in a couple different places, but it's still just x. As long as you only have one variable, you can solve it. Question? You could rearrange this equation all you want. It's a big waste of time. All the rearranging you do of this equation at the beginning doesn't save you any time once you plug this in. Because as soon as you plug this into here, you're going to have to distribute and combine a bunch of like terms anyway, and it really doesn't make a difference. So now that I've plugged this in, the next step is to distribute. We do have parentheses inside of an equation, which we should always think is distributive property. 3 times negative 2x is negative 6x. 3 times 6 is 18, and the rest of the equation stays exactly the same. I have some like terms. Negative 6x, negative 1x. Positive 18, positive 3, my constants. Negative 6 minus 1 gives me negative 7x. Positive 18 plus 3 is plus 21. That still equals 0. It's a two-step equation now. So I'm going to subtract 21 on both sides. Negative 7x equals negative 21. I'll divide by the coefficient, negative 7. And I get that x equals 3. This is half of my answer. Going back to what this is, the purpose of this, what are we trying to find? If you're solving a system of equations, we are finding where those two lines do what? Where they meet, where they intersect, where they cross. So my final answer, if I'm going to find where two lines cross, my final answer should be a point, x comma y. Right? It's on a graph. But now we know what x is. X is 3. So there's the first half of my answer. X is 3. For the second half of my answer, I want to know what y is. Well, now that I know what x is, I can take this and plug it back into the beginning. We can do a little mental math for this. We're not going to write it out. If I plug in 3 for x, what's negative 2 times 3? Negative 6. Plus 6? 0. So y equals 0.